Hi everyone, welcome to lecture 2, and in this lecture we are going to look for the conditional probability. Okay, so the conditional probability provides us with a way to reason about the outcome of an experiment based on some partial information. Actually we can summarize this conditional probability, or we can define it. You will be asked for a probability of some events, but also you will be given some information, and you have to use that information to calculate the correct probability of that particular event. So we can give some examples for the conditional probability. Let's say we have a die and two successive rolls of die is an example of the conditional probability, such that we know that the sum of two rolls is 9. And if you are given that the first roll is 6, and then instead of looking for 36 different pair of the dice, you will only sum part of them. Like, let me show that. So let's say we have the first roll and the second roll, right? So this can take like 1, 1, 1, 2, etc. And there are 36 different pair, right? So instead of looking at 36 pairs, you will only look for the first roll is 6. So you will only look for 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. And that means you will reduce the size of your omega, your sample space. And this is the main logic behind the conditional probability. Another example is the word guessing game. And let's say the first letter of a word is T. And what is the likelihood that the second letter is an H? So again, this will reduce the size of your omega, your sample space, right? Instead of looking all of the words, just you will look at the words which its first letter is T, right? And another example is a spot show up on a radar screen, and how likely is it corresponds to an aircraft. So this spot on the radar screen is given to you, right? And you will use this information to calculate the probability. So to summarize all these things, to understand the logic behind the conditional probability is that different from the lecture 1. In this part, in the conditional probability, you are given a piece of information, and you will use that information to calculate the probability of some particular events. So given an experiment, we have a corresponding sample space and the probability law, right? And as we study in the lecture 1. And suppose that now we know that the outcome is within some given event B, and there's partial information here as defined as B, okay? And we wish to quantify the likelihood, the probability that the outcome also belongs to some other given event A. So the given information is the given information is B, and we want to calculate the probability of A, okay? If this is the case, we construct a new probability law that for any event A specifies the conditional probability of A given B, and we denote it by this, okay? Probability of A given B. So this is the conditional probability. So again, let's continue with an example, and just consider a single roll of a failed die, right? And our sample space, our omega is the numbers from 1 to 6, right? And if we want to calculate the probability of a single event, we can simply say that these are uh, these are these have the equal probabilities, and we can calculate at 1/6. Like, don't remember that this is an omega, right? So we can calculate the probability of this uniform events. So, and here the probabilities are I mean, these outcomes are equally likely. So the probabilities of that single events will be same. But now let's say, suppose that we know that the outcome is even. So the size of the omega, the sample space will reduce, right? So we are left with only 3 possible outcomes. These are 2, 4, and 6. Why? Because this information is given in advance, right? Here, the outcome is given. So these 3 outcomes is equally likely as we did before. So let's say the event A is 6. Okay, so I mean, the whole question should be, what is the probability of getting 6 if the outcome is even? Okay, so the partial information here is the outcome is even. So in this case, the probability of A given B will be 1/3, because the omega, the size of omega now is 3. Okay, so we don't need to look at, or we don't need to consider the other outcomes 1, 3, and 5, because these are not true based on the given information. So if we generalize these rules, and if we have a uniform model, means all the events or the outcomes are equally likely, this suggests that the probability of A given B can be calculated by the size of the A intersect with B divided by the size of the B. Okay, as we did in the die example, like event A was 6, right? I mean, the getting 6 after rolling a die, and the size of the event of A is 1, and the size of the given sample space, or the created sample space based on the given information, is 3, 2, 4, and 6. So if we more generalize these rules for any kind of model, we can write the conditional probability P of A given B such that P of A intersect with B divided by P of B. Okay, probability of A intersect with B and divided by probability of B. So we can define this conditional probability of an event A given an event B with the probability of B will be greater than 0. Why? Because if this would be 0, then that would be that will be the undefined, right? Because this will be the denominator will be 0, and this part will be undefined. So the conditional probability specifies a new probability law on the same sample space omega, right? So we can say that all the probability axioms are valid for the conditional probabilities, all properties of the probability. So you can verify these things at home. I mean, we did in the first lecture, we use the axioms and we write some other useful properties, and you can do same thing for the conditional probability. Okay, if you cannot do that, please check the book, and there are some validation in there, and you can test yourself. And also, the conditional probability can also be viewed as a probability law on the new universe, P, I mean, new omega. So, and because of, and because all of the conditional probability is concentrated on the B, right? I mean, that will be our new omega, and we can we can consider all probability law will be valid in the new universe. So before going to examples, I just, let's say this is condition P of A given B is equal to P A intersect with B and divided by P B, right? So let's write this one. Probability of B given A this time will be again P A intersect with B divided by P E, right? A. So please don't memorize these things, but try to understand the logic behind this formulation. Okay. So let's say we have two events. Okay. Let's say this is an A and this is the B. A has some points. Okay. And B has some points. So this part is common, right? These 2 points belongs both A and B, right? So what I'm looking for here, the probability of A, okay? I mean, these points. But the information is, it's saying that given B. So that's mean actually, look for the points. They are also in B, okay? So I can simply regard this part, okay? This part. Because this conditional probability or partial given information told us, look at the points in that region, okay? That region, B. Let me change the color. So among this B, which part is coming from also A? Which points are also belongs to the A? This part, right? This 2 part. And what is this part? This is A intersect B, right? So now my space, I mean, like, delete this, okay, redraw this one. So now I'm looking this part. There are 2 points here. Okay, 3 points here. This whole things is B. And also this is a new omega. Okay, it's a new omega. Let's say omega star. And this part is A intersect B. So what is the probability of getting these points? Simply this part divided by whole part, right? So this part is corresponds to A intersect B, and this whole part is B. Okay, please try to understand the logic behind this formulation and don't memorize these things. Okay, so let's do this same thing for this one, the second one. In this case, I will look for P probability of P given A. Okay, and again, I have 2 events. And again, have some points. Okay, so what are we given? We are given that we are gonna look the points only in region A. Okay, so I'm gonna look only this region. Okay, so I can disregard this part. Okay, so this is again A intersect B. So what is the probability of getting this 2 points? Simply this region divided by this whole region. And in this case, A will be my new omega. Okay. So I can divide, if I divide this region to whole region, I will get the probability of getting these 2 points. So it's simply A intercept B divided by A, right? Same. Okay, please try to understand the logic and do it yourself and understand the logic behind the conditional probability. Okay, I will see you in the part 2.